Okay, so in our next section of Chapter 8, 8.2, what we're going to be taking a look at here is adding and subtracting of the rational expressions. Now, in Section 8.1, we first looked at simplifying, okay, and the importance of the factoring there, because you have to factor and then look to see what simplifies. With the multiplying and dividing that we also did in Section 8.2, one of the first things that you had to do was a lot of factoring, and then you look to use the fundamental principle of fractions to once again simplify your expression. With adding and subtracting, we will also have to do a lot of factoring. Okay, so once again, that key skill of factoring is going to be an underlying concept that we must be comfortable with. So before we get into the harder problems, let's just review how we have to add and subtract, let's say, numerical fractions. Now, there were two different types. Remember, in order for us to be able to add and subtract numerical fractions, one thing needs to be true, and you must have the same denominator. Okay, for example, if we have, let's say, 3/7 plus 2/7, remember, when we are adding, in this particular case, these two numerical fractions, since they have the same denominator of 7, you don't do anything with that. You leave it. And then what did we have to do? Well, we're going to take the first numerator plus the second numerator. And then, of course, when we combine the like terms, 3 plus 2 would give us, of course, 5/7. And once you're done combining the like terms in the numerator, the 3 plus the 2, to give you the 5, you always ask yourself, can you simplify 5/7? And, of course, the answer is no. 5/7 is already simplified, and therefore that would be the answer. So here we were adding numerical fractions, let's say, with the same denominator, because we need to have the same denominators in order for us to add or subtract numerical fractions. Speaking of subtraction, let's say we have 16/15, and we want to minus, let's say, 6/15. Well, now once again, we have like denominators, the same denominator. So we're not going to do anything with that denominator. We're going to keep it. Except now, once again, we're going to take the first numerator, 16, and we will now subtract the second numerator, 6. 16 minus 6 in the numerator, that would give us 10/15. Now, 10/15 is not the simplified answer because 10/15 itself can be simplified. In that, the number 10 I can write as the factors 2 times 5, and the number 15 I can write as 3 times 5, and here we would use the fundamental principle of fractions and simplify the 5 on top with the 5 on the bottom, giving us the correct simplified answer, 2/3. Okay? So after you've combined, whether it be through addition or subtraction, after you have combined what you can in the numerator, you look to see if you can overall simplify that answer, okay? Because your answer must be expressed in simplest form, okay? Let's try one that involves some algebraic fractions, okay? For example, let's say we have 3x minus 7 over 10x squared. And we want to add to this x plus 7 over 10x squared. Now here, once again, just like in the previous two problems, here we have the same denominators of 10x squared. So we are going to keep that denominator of 10x squared. Now what I'm going to do is I'm going to take my first numerator, of 3x minus 7, and I want to add to it my second numerator of x plus 7. Okay, just like we did here, we took the 3 plus the 2, and just like we did over here, we did 16 minus 6. Here I'm going to take the first numerator, and it's a polynomial, so I'm going to keep it grouped in parentheses, plus the second numerator, also a polynomial, so I keep it grouped inside parentheses. Now, as always, we want to combine what we can, combine like terms, in the numerator. So if I take this 3x and I add to it a 1x, that would give us a 4x. And then if we take the negative 7 and add to it the positive 7, that gives us 0. So we are left with a 4x over a 10x squared. And that could be simplified, because the factors of 4 I could write as 2 times the x. The 10x squared I could think of as 2 times 5 times the x squared. And since we have a 2 on top and 2 on the bottom, they simplify. So we're going to have the numerical part of the fraction of 2/5. And here, like we learned way back in, I believe, chapter 6, when we are dividing the same variable, we have to subtract the powers. And since x is larger in the bottom, x will stay there. And if we do 2 minus 1, we're left with 1, x in the denominator. So we have 2 over 5x as your simplified answer. Let's try another one. Let's say we have 3x plus 5 over 4x minus 7 over 4x plus 2 minus x over 4x. So we want to combine these rational expressions. Now, luckily, they all have the same denominator. So once again, what are we going to do? If they have already the same denominator, we're going to keep that denominator. And now I'm going to take my first numerator, the polynomial 3x plus 5. I will then subtract the second numerator of 7, plus, then we have this third numerator, which happens to be a polynomial 2 minus x. Now let's combine our like terms. Let's start with the x terms. I have 3x here, plus a negative 1x here. That, of course, would give us a 2x. Then we're going to take the positive 5, and I will minus 7. Well, 5 minus 7 would give you negative 2, plus 2 would give you 0. Now let's take a look at what we can do to simplify 2x over 4x. Well, the x in the numerator and the x in the denominator will simplify, and 2/4 can always simplify to a half, and that would be your answer for that one. Let's try another one. Let's say we have x squared minus 8 over x squared plus 5x minus 7 minus 2x over x squared plus 5x. Now, once again, these two rational expressions already have the same like denominator. So we are going to keep that denominator. And now I must take the first numerator, the polynomial x squared minus 8, and I need to subtract now the second polynomial, the second numerator of 7 minus 2x. So now I'm going to keep that denominator the same, and now I want to combine whatever like terms I have in the numerator. Well, I have the x squared, That's going to stay. And then I notice here that I am subtracting a negative 2x. Well, subtracting a negative 2x is the same thing as adding a 2x. And then lastly, we have negative 8 minus 7. That, of course, would give you a negative 15. Well, that's not our answer because, as always, we look to simplify. Simplifying means we look to see if we could do any type of factoring. Well, the numerator is factorable, so let me set up my parentheses. Factors of x squared, of course, would be x and x. The minus 15 would mean one of these numbers is positive, the other is negative. And then factors of the negative 15 that would add up to a positive 2 would have to be a positive 5 and a minus 3. The denominator, from a factoring point of view, I could factor out a common factor of x, and in doing so, that would leave me with an x plus 5. And so, the x plus 5 in the numerator and the denominator are the same factor, and therefore they would simplify with one another, leaving me with now x minus 3 on the top and an x in the bottom. And that would be your simplified expression. Okay. Now, in all of these examples that we did, okay, whether it be the very beginning ones, when we were dealing with numerical problems, or whether we were dealing with the rational expressions, they all had one thing in common, and they all had common the same denominator, okay? But we know that not all fractions, whether they be numerical or rational, algebraic nature, they won't always have the same denominator, but we can still add and subtract. But what we have to do is we have to form the same denominator, because when you add or subtract, one thing we know for certain, you must have the same denominator. Now, let's take a look at a numerical problem, and let's recall what we had to do back when we first learned how to add fractions of a numerical nature. For example, let's take 2/3, and let's say we want to add 4/5, and then we want to also subtract, let's say, 1/6. Now, we cannot combine these fractions the way they currently are because they do not have the same denominator. But what we want to do is we want to change these fractions. We don't want to change the value of the fraction, though. We want to just change the way that fraction of 2/3, 4/5, and 1/6 look. And we're going to try to form the same denominator, preferably the lowest common denominator, and I abbreviate it LCD. We are looking for a number that 3, 5, and 6 can divide into evenly. The smallest number that is divisible by 3, 5, and 6. And if you go through your number system, okay, you will find that the smallest number that is divisible by 3, 5, and 6 happens to be the number 30. Okay, 3 goes into 30, 5 goes into 30, as does 6 goes into 30 evenly. Okay, and that is the smallest number where that is true. And so here's what we want to do. We want to change these numbers, and we want to turn them into equivalent fractions that have 30s in the denominator. Okay? So here's what we're going to do. What would I have to multiply 3 by to get a 30? Okay? And of course the answer is the number 10. So what I need to do is I need to multiply this fraction of 2/3 by a number in the form of 1. By multiplying by the number 1, okay, a number stays equivalent. 3 times 1 is 3. 7 times 1 is 7. Okay? Any number times 1 is itself. But I'm not going to just multiply by the form of 1 like this. Okay? I'm going to multiply by a very special form of the number 1. I want to multiply by the fraction 10 over 10. Because any number divided by itself is also the number 1. And if I multiply 3 times 10, we will get 30. So if I multiply the 3 with the 10, I also have to multiply the 2 with the 10. And so 2/3 is the same thing as 20/30. So these two fractions are equivalent, but at least this one now has the denominator that I'm trying to form. Now let's take a look at the next fraction, 4/5. I have to once again multiply by a form of the number 1. So what would I have to multiply 5 by to get the number 30? And the answer, of course, is 6. So the form of 1 that I'm going to use is 6 over 6. Because now 6 over 6 is 1. And when I perform the multiplication now, 4 times 6 would give you 24, and 5 times 6 would be 30. So 24/30 is the same thing as 4/5. They are equivalent. Finally now, we have to multiply the fraction 1/6 by a very special form of the number 1 in hopes of creating a 30 in the denominator. Well, what would I have to multiply 6 by to get the number 30? Of course, the answer is 5. So my fraction must be of the form 5/5. And when we perform this multiplication, 1 times 5 is 5, over 6 times 5, of course, was 30. So the original fractions that we have here in black are equivalent to these fractions that we have here, except now they at least have the common denominator of 30. And so we are going to keep that denominator of 30, and I'm going to take my first numerator, and I will add the second numerator, and then ultimately subtract the third numerator. I will combine what I can. 20 plus 24, of course, that would be 44. 44 minus 5, that, of course, would give us now a numerator of 39, and the denominator stays 30. But remember, can we simplify this? Well, 39 can be thought of as 13 times 3, and the number 30 can be thought of as 10 times 3. And so the fundamental principle of fractions now, we can use that to further simplify our answer, because the 3's would simplify top and bottom, giving us now the final simplified answer of 13/10. Okay? So with adding and the subtracting of rational expressions of these algebraic fractions, we must always have a common denominator. If we do not have a common denominator, we're going to create one, preferably the lowest common denominator. Let's try another one. Let's say we have 5 over 3x squared plus 7 over 2x to the third. Now these don't have a common denominator, but once again we're going to try to form, we need to come up with what is the lowest common denominator. Well, let's start with the numbers. With the numbers 3 and 2, your lowest common denominator is, of course, 6. Next, we have some variables. We have an x squared, and we have an x cubed. And when it comes to the lowest common denominator, you're always going to go with the higher exponent. So x to the third is also the highest, part of the lowest common denominator. Now remember, once again, what we have to do is we have to form two new fractions with this lowest common denominator. So once again, we're going to have to multiply by very special forms of the number 1. Well, what would I have to multiply 3 by to get a 6? And of course the answer is 2. 2 on the top and 2 on the bottom. Let's also take a look at the variables. I have an x squared and I want x to the third. So I'm going to have to multiply by a missing x. Let's perform our multiplication now. And in doing so, 2x times the 5, that would give us a 10x over, when we perform the multiplication in the denominator, we get 6x squared plus. Next, let's change this denominator and form the lowest common denominator. What would I have to multiply 2 by to get 6? The answer would be 3. I have x to the third, and that's what I want, so I don't need any additional x's. Let's perform this multiplication now. And so 7 times 3 would give us a 21 over 2x cubed times 3 is, of course, a 6x to the third. Well, we have just created two equivalent fractions that have a common denominator. And when we do that, now we can resort back to what we did prior, in that I'm going to take the same common denominator of 6x squared. I take my first numerator of 10x, and I will add to it the second numerator, 21. As always, we look to see, can we simplify? And in this particular case, there's nothing that we could do from a factoring point of view to further simplify this answer, so here it is. Let's try another one. One that's a bit more challenging. Let's say we have 2x over x squared minus 1 plus 1 over x squared plus x. Now here's where it's going to start to get a little bit more complicated. In order for us to come up with the lowest common denominator, let's take a look at these denominators first. If possible, if there's a possibility, when you're looking at your denominators, and if they are in any way factorable, you want to factor first your denominators. So if possible, okay, if there's a possibility, first factor any denominator. So let's take a look at these denominators. So I still have 2x, but this denominator in the first fraction is the difference of two perfect squares, and I'm going to factor it down into an x plus 1 times an x minus 1. That's the factored form. Next, let's take a look at the second fraction. From a factoring point of view, we can factor out a common x as the greatest common factor. By taking out the common factor of x, we'll have x times x plus 1. Now, the lowest common denominator, okay? Because remember, we have to always form the same lowest common denominator. Listen to what I'm going to say. The lowest common denominator is made up of each different factor of the denominators. Okay? Let me repeat that. The lowest common denominator is made up of each different factor of the denominators. So let's take a look here. I have x plus 1. That's one factor. I have a different factor in the denominator, x minus 1. That has to be there. I have this different factor of x. That's going to make up the lowest common denominator. X plus 1 is already there. Okay? So once again, the lowest common denominator is made up of each different factor that makes up the denominators. So that's why I need to have the x plus 1, the x minus 1, as well as the x, because those are all different factors. Now, to form this lowest common denominator, in essence, you have to now go and you want to multiply by what's missing. So I look at my first fraction. It has the x plus 1. It has the x minus 1. The only thing that's missing is the output x. So I'm going to multiply the top and bottom by x. Next, let's take a look at the second fraction. It already has the x. It already has the x plus 1. But what's missing from my denominator is the x minus 1. So I have to multiply the top as well as the bottom by x minus 1, because that's what's missing. You always multiply by what's missing. Now let's actually go and let's perform the multiplication of the first fraction, but only the numerator. X times 2x would give you a 2x squared over the common denominator, x times x plus 1 times x minus 1. Plus, next we have to perform this multiplication. 1 times x minus 1 is simply x minus 1 over x times x plus 1 times x minus 1. So let's take a look at what we did here. The first two black fractions that we had didn't have a common denominator. Then we created this second pair of black fractions with factored forms of their denominator. Then we created, by multiplying by forms of 1, we created these two red equivalent fractions, but at least now they have the common denominator. Once they have the common denominator, now we proceed like we did in the previous problems, in that we are going to now keep the denominator of x plus 1 times x minus 1. I take my first numerator of 2x squared, and I add to it the second numerator of x minus 1. Of course, though, we never stop here. We always ask ourselves, can we simplify this answer? And the answer is, of course, yes, because we have an x plus 1, and an x minus 2 in the denominator. Sorry, that should be an x minus 1. This denominator is factorable, so let's factor it down. The factors of 2x squared, 2x, and x. We know our signs are going to be different. I'm going to have to put a plus 1 here and a minus 1 there. And that is our factored form. And since we have the same factor of x plus 1 on top and bottom, that 2 can now be simplified, giving us now 2x minus 1 over x times x minus 1. That is your simplified answer. Let's just try one more. All right, one that's kind of challenging. For example, let's say we have x over x squared plus 5x plus 6. I'm going to subtract 2 over x squared plus 3x plus 2. Now, once again, these two fractions don't have the same common denominator. I do look at these denominators, and I do recognize the fact that they are factorable. So we want to factor down first each of these denominators. So I'm still going to have x, except now I'm going to have the factored form x and x plus minus, and of course the factors of 6, sorry, that should be plus plus, right, because it's same sign, both positive. I need 2 factors of 6 that add up to 5, and of course that would be 2 and 3. Then we're going to subtract. I'm going to now factor down the second denominator, set up my parentheses. Factors of x squared, once again, x and x. This time I also have the same sign, both positive. Factors of 2 that add up to 3, of course, would be 1 and 2. And so now, once again, we need to come up with the lowest common denominator. Once again, each different denominator needs to make up the lowest common denominator. So I have an x plus 2. I have an x plus 3. I also have an x plus 1. It is these 3 parts being multiplied together that form the lowest common denominator. I don't have to include the x plus 2 a second time. And now, to form your common denominator, once again, we need to multiply by what is missing. So I take a look. What's missing from this first denominator? Well, it has the x plus 2, it has the x plus 3, but what's missing is the x plus 1. Multiply the top and bottom. And let's do that. So this new fraction will become x plus 1, x plus 2, x plus 3. And then on the top, when we multiply, x times x plus 1 would give you an x squared plus x. Then there's a minus sign. Now let's take a look at what we're going to have to multiply the second fraction by. I have to multiply by a form of 1. It has the x plus 1. It has the x plus 2. What's missing is the x plus 3. So I multiply the top and bottom by x plus 3. So the denominator, once again, will remain x plus 1, x plus 2, and x plus 3. And so now 2 times x is 2x. 2 times the 3, of course, that would be a plus 6. So now we have the 2 equations with different denominators. Now we have 2 expressions, different denominators but in factored form. Now we have here in red 2 equivalent fractions, but at least they have the same denominator. And so now what I'm going to do is I'm going to actually keep that denominator the same. I'm going to keep the denominator of x plus 1, x plus 2, and of course x plus 3. And when I combine, I have the x squared. I have this positive x minus 2x. Well, x minus 2x, that of course would give us a negative x. And then I have to now subtract 6. As always, we look to see, can we factor? Can we simplify? So I look at my numerator, and it is factorable. So I'm going to factor it down to an x minus 3 and an x plus 2 over, of course, that common denominator of x plus 1, x plus 2, and of course x minus 3. As always, we look to see if we can use that fundamental principle of fractions, and sure enough, the x plus 2 on the top and bottom simplify. What remains is the x minus 3 on the top, and on the bottom we have x plus 1 times the x plus 3. And that is your simplified expression. Okay. So that completes section 8.2. the adding and the subtracting of rational expressions. And once again, you're looking to make sure that they have a common denominator. If they already have the common denominator, merely combine like terms in the numerator and simplify. If they don't have a common denominator, as we've been seeing in these last examples, you have to form the lowest common denominator by multiplying by a form of 1. As always, send me any emails with any questions or concerns that you may have about the homework that goes along with section 8.2. Until the next time, be well.